Yep. So I shall start with the problem statement. So this problem statement was given to me by my co-author, who is a practitioner in fixed income as well as equity research. So the problem statement is something like this, that whenever a company applies for an IPO, they have to submit to the whole public as something called prospectus, which you might have seen during IPO. So prospectus is also called as offer document. So whenever you are raising a money, for example, you are raising money in stock exchanges, you have to disclose some things. For example, what are your different risks, where the money will be utilized post you raise that money, and are there any litigations on your company and related party transactions, any transactions which are happening within the different organization or related companies which are associated with that organization. Now, the problem statement is something like this, that this thing is, first of all, public in nature. So this document is already available in regulatory filings. Unfortunately, what's happened is that analyst as such who needs to create some reports or who need to evaluate the credit worthiness of this company has to go through manually and find out, different aspects. For example, are there any litigations? So they have to literally go and search. So what we thought was that, can we use NLP and machine learning to create a information retrieval system? So all of these things will go into a specific system, and you can then use something like semantic search to find out different aspects of business. For example, you can have something called currency risk. So you might have a statement like, we have currency risk associated with this much amount, but that sentence can be written like, we have a forex risk also associated with this thing. You can write a sentence something like that, our remuneration for directors will be, XYZ amount, but you can also write something like, the bonuses will be given to directors and the bonuses are XYZ amount. So you want to do a semantic search. So is it possible to do it? So this is the problem statement. So in the end, what we wanted to do is all this unstructured information, which is available in prospectus, we wanted to put it in an information retrieval system and do a semantic search on top of it, so that similar sentences we can identify. That's the problem statement that we are solving. So yeah, this is what we did as such, and this is a very, very preliminary work. So again, as I told you that the data is publicly available. So we collected 100 prospectus, and 100 is a very good amount because the number of pages in a prospectus is pretty much large, which is like 400 to 500 pages, and it contains every disclosure that you have to do, which are there by the market regulator. For example, as I talk about all the risks you have to do, all the litigations you have to do. So it's a very, very rich information for anybody who's doing fixed income or equity research. Now the total number of pages that so for this specific exercise, the total number of pages that we found were 41,697 pages. And again, as I told that, there are 400 plus pages per prospectus. So for 100 companies, we were able to extract these many pages. So we converted those PDF images into OCR text. And the total number of words that came out of this was around 2.2 crores, so 22 million. So here is our contribution in this paper as such. So the number one was that we have a public data set. We extracted the raw text, which is the OCR text from it. The second thing which we did was something called creating prospectus STS. STS is semantic textual similarity. So what we did was, again, I will show you next is that, what we created was sentence pairs. The example that I gave you, that, for example, Forex and currency are the same thing. Are they same thing or not? So we created those sentence pairs and put it into one data set, which can be used further. What we also did was, and this is primarily done by my co-author, which is, putting against those sentences different labels. So this sentence, for example, is talking about accounting standard. Are they talking about remuneration? They are talking about utilization of fund and so on. And this is very, I would say, pragmatic as such, because a real person who does it manually actually has around 200 categories. So they see, across the whole prospectus, they see different 200 categories and just, pull that information. So for starting, what we are trying to do is just put it into 18 classes, but yeah, later we are going to expand it. The next contribution that we did was we created a large language model based on these 22 million words, and this is nothing but Roberta. Roberta, as such, is just an improved version of something called BERT in the language model era. So it's like slightly better. So that's what thing which we did. The another thing which we did was, based on this, we found something called sentence transformer. And this application is pretty much simple. Once you have a sentence transformer, you can embed any sentence into it. It will give you some fixed vector. And this vector can be used then for information retrieval. So if they are semantically similar, you fed a sentence into a sentence transformer, we can find out and search which are the similar sentences which was fed to the earlier sentence. So that is the application of the sentence transfer. So this is what our contribution is. Again, this is pretty much preliminary because 18 classes as per practically a real person sees more than those classes. But still, it's a unique contribution because as far as we understand, at least in Indian market, that is something unique. Our understanding is, at least at this time, nobody is doing it. But yeah, there are many people doing it Wall Street that we know of. So that's our contribution. So again, from the prospectus, corpus preparation was pretty much easy. So we had something called PDF using some tool called Poplar. We converted those PDF into JPEG images. Then we use Tesseract OCR, which is an open source OCR. And we, aggregated different JSON files. So all this PDF is actually converted into text. And this text is fed into our language model, Roberta-based language model, and for the sentence transforms. So this is how our semantic textual similarity data looks like. And this is a real example of what we have done. So like, for example, you can see there are two sentences in A and B. So you have some sentences. Now the next one, which is C, is nothing but a class label. So against each of these sentences, we give a class label. And we also give, some number of whether they are similar or not. So for example, here, if you see the last sentence, which is we have included certain non-GAAP financial measures and so on. And if they are like pretty much similar, we'll put it as 1. If they are not, we'll put it as 0. So that is what whole STS data set is all about. Yeah. So this is what we evaluated. So there are two things we evaluated. We just presenting the STS results. So what we did was based on this data set that we created here, for example, 1 or 0, whether these two sentences are similar or not. We evaluated something called Pearson and Spearman correlation coefficient. So it is nothing but when you fed into two sentences, you will get some vectors. These vectors you can compare and find out the cosine similarity score. And this cosine similarity score, you can, compare with the S column as such. So what you can get is the Spearman or Pearson correlation coefficient. The idea is if you have something pretty much higher, that means if you are comparing, for example, here 3 things, in our case, our sentence transformers, because it has a higher score, that means it specifically performed better than 2 already popular sentence transformers. So our one was 3rd, and what we saw was that it performed pretty much better. The reason was pretty simple. The first 2 are more generic in nature. The 3rd one, since we have trained from scratch on our own data sets, that is, it contains those unique features for the prospectus domain. That's why the scores are pretty much high. But that was our intention to, rather than making it a generic or specific language model, try to use a prospectus or our draft of a document based sentence transformers for better accuracy or better results. So this was the results that we get. Again, as I told you that this was a very, very preliminary work as such, because 100 prospectus is again a very small thing. But what we wanted to do is, first of all, expand number of labels and examples. As I told you, we only had 80, but in a real scenario, there are like 200 labels that you can give. You can increase the number of examples. That is the one objective we wanted to achieve. The second objective, again, not written here, was that we also wanted to have more annotators for it. So this exercise was done by a single author as such with his domain expertise. But again, we have something called inter-annotator agreement, where even the same annotators can differ. So what we wanted to do in future is apply at least more annotators so that we get a more richer data as such. That's the thing which we wanted to do. Again, what we wanted to do is use more language models. So for now, we have used, like as I told you, Roberta. But again, Roberta has some limitations of having some fixed sizes of sentences. But there are some language models which can go up to 4,000 characters. So the span of sentences is pretty much larger. That's what we wanted to try. Maybe bigger and have more sequences. Those kind of language models. As of now, what we have done is we have only defined a problem statement of STS, which is semantic textual similarity. But there are many application areas that we can apply. For example, we can have NER problem also defined. So where we can find out different parties within, let's say, this prospectus. For example, there are bankers associated with prospectus. So can you find out those different bankers? Are there different parties? Can you find out different amounts? Those sort of problems we can define. And those are practical problems that actually people do. For example, let's say whenever a merger acquisition happens, the first thing you will need to know is, what is the deal? Who are the bankers? Who are the third parties? So that's you wanted to do. Again, there are other problem statements that we wanted to solve. So one pretty much simple example is, zero-shot learning assets. So let's say whatever class labels we have defined, can we have a zero-shot learner applied? Further, we can have few-shot learner applied. So those sort of problems we can further enrich. That's our future planners. So yeah, I think it was a short presentation. Yeah, but yeah, I am open to any questions and answers.